All right, we're going to pick up in Chapter 1, Section 3 with stretches and shrinks to functions. Excuse me. We have already talked about translations of functions, the left and right, the h and the k. We've already talked about reflections, both horizontal and vertical. When the trick with the horizontal, it goes in by the x only, but then we have to factor that out. We looked at the math for that. The trick on that is actually it just ends up changing the sign on the back side. So then we looked at reflection in the y, and that's negating the whole equation. So you distribute the negative all the way through. And now we're going to look at stretch and shrink. The tricky one is horizontal stretches. Okay, and the tricky part comes in right here. When you do f of ax, the factor that you stretch or shrink by is 1 over a. So we have to take a reciprocal. Okay, we have to take a reciprocal. And I'm sorry for the weird sound in the background. My dog is drinking water. So just like whenever we put the h in there and we have to make it the opposite sign, when we put the a in there, we have to make it the reciprocal, to flip it over. Okay, so if it wants me to change by a factor of 2, so if it's by a factor of 2, the a I'm going to put in is 1 over 2, which is a half. If they want a factor of 1/2, my a equals 1 over 1/2, which is 1 divided by 1/2, or 1 times 2 over 1, which is a 2. So we take that reciprocal, and you'll see on the example that I do on the next slide. Now, a vertical stretch or shrink, you take that a value, whatever it is, the factor that they want you to use, and you just multiply the whole problem by that. So there's no change to it, but it gets multiplied times everyone. With the x, or the horizontal, it flips reciprocal, but it only multiplies by the x. Okay, so let's look at an example. We've got let f of x equal the absolute value of x minus 3 minus 5. We're going to write a function g, so this is part A, write a function g of x, whose graph is a horizontal shrink of the graph of f by a factor of 1/3. Okay, now the key there is horizontal. That means I'm going to have to flip it. Okay, so when I take the 1/3 and I bring it down and I plug it into my problem, I've got to flip. So I'm going to bring down the absolute value. I'm multiplying something times x minus 3, absolute value close, and then minus 5. And I'm taking that 1/3 and I'm plugging it in down here, and I've got to flip it to make it a 3 over 1, or just a 3. Then we just simplify what we can, which this one there's not much to do. G of x equals 3 times x, which is 3x, minus 3, minus 5 stays on the outside. Now that's in contrast to a vertical change. On B, we want to write one that's h, that is a vertical stretch, keep it, and multiply it times the whole thing. So h of x, we're going to stretch by a factor of 2 the whole entire problem. So we distribute the 2 to the absolute value and to the negative 5. So the h of x equals 2, absolute value x minus 3 minus 10 now, because 2 times 5 is 10. So that's what those are going to look like. Now it's going to vary depending upon which family you're talking about. Linear gets a little different, squared gets a little different, absolute value is a little bit different. So let's try a couple more examples. Give it a pause. Try 5 and 6 here on the screen, and then I'll work them out afterwards. You can see how well you did and where you messed up. Okay, let's look at number 5. They want us to name everything g, so I'm going to call it g of x. And they want me to take the original equation. They want me to do a horizontal stretch by a factor of 2. Okay, so when I flip that, it's going to be 1/2. Remember, horizontal, you got to flip it over. If you're multiplying, you flip. If you're add or subtracting in, you opposite. Okay, so my horizontal stretch, I'm going to flip it over. So I've got 4 times something times x plus 2, because I'm only doing it to the x area. I'm going to do that 1/2 in here. So g of x equals 2 now, because 4 times 1/2 is 2x plus 2. Now I want to look at that in a little bit different way. Let's say that number 5 wanted me to use f of x equals 4 times x squared plus 2. All right, so when I make it my g of x and I leave my 4 and I'm going to multiply something times x and it's squared because it goes inside the parentheses with the x, so we single the x out and we're going to put it inside there plus 2. If I put a 1/2 in there, that changes things up a bit because now the squared applies to the 1/2 and to the x. So that leaves the 4 there. It makes it 1/4. And now x squared plus 2. And then it goes 1/4 times 4 is 1. So it's just x squared plus 2. So you can see how you get different things if it's a different family of information. And it's even more different if it's absolute value, because you can't actually do a distribution of the absolute value as well. I mean, you can separate it into the absolute value of 1/2 times the absolute value of x, and you could do a positive of that, but you're not supposed to. Okay, so just be careful with how you do your distribution inside here. Now let's look at 6. It's a vertical shrink. Vertical, we keep it. Okay, k, we keep the sign. K, we keep the factor. H, we take the opposite sign. And then horizontal, we flip it over. Okay, so I'm going to make g of x equal to absolute value. I'm going to multiply something times x and then close it minus 3. That's something. I'm going to take that 1/3, plug it right in. Okay, plug it right in there, and we're done. Pretty easy to do. Okay. Now you could go on to simplify this, because you could say g of x equals the absolute value of 1/3 times the absolute value of x minus 3. And the absolute value of 1/3 is 1/3. Now, if you notice, oh, I totally did that wrong. Well, failure is always an option. Why did I put it in by the x? It's a y thing. All right, let's look at the right way to do that. For number 6, g of x equals something times the absolute value of x minus 3. And we're going to do that 1/3 times the whole problem, because it's a y. It's not in with the x, you silly teacher. It is a whole problem thing. We're going to take this whole thing, the absolute value of x minus 3, which gives us a y, and we're going to multiply it by 1/3. There we go. Now we distribute times the 1 in front and times the negative 3 in back. So g of x equals 1/3 the absolute value of x minus 1 now, because 1/3 times negative 3 is negative 1. There's the right answer. Goodness gracious me. Okay. Combinations. So doing more than one thing at a time. Very easy to do. One at a time in the stated order. So whatever they tell you they want to be done, do it in that order. one at a time. So let the graph of G be a vertical shrink by a factor of 0.25. So we're going to vertically shrink by this, so we're going to keep it. We're not going to flip it. Then we do a translation 3 up. And we're using the graph of f of x equals x. We're going to write a rule for G. So our G of x, and this is phase 1, we're going to do a vertical shrink by 0.25. So it's 0.25 times the whole equation, which is very small. It's just an x. Okay, so then we get G of x equals 0.25x, and then we're going to do the 3 units up. That's a k. It goes on the back. Plus k. Okay, so we're going to put plus 3 units back there, and we simplify what we can, and there's nothing left. So it goes right here. Now you could do it all in one move. You could say G of x is 0.25 times the x, and then add the 3 all in one line. Because of PEMDAS, the multiply has to come first, and then the add comes second. Okay. If we wanted the add, if we wanted to raise it 3 units up and then shrink it by a factor, okay, that would be a different problem. If we wanted to do that, we'd put the 0.25 on the outside, and we put the plus 3 inside because we'd want to add the k to the back of the equation. Then we want to do the multiply, and the parentheses help us set that off. It's just an associative thing. Okay, instead of, right, coming through there, instead of it being this first, we get to make that happen first. Okay, that's the main difference that's happening between them in order. Main thing is do it one at a time. Do piece and piece, and you'll have no problems. And lastly, let's talk about a word problem. So the word problem sets up the same scenario. They give us an equation. They want us to transform it. Now here's the tricky part. $50 less than 90%. That less than is not the symbol for less than. If it says $50 less than 90%, it does not mean this symbol. That's a no-no. This symbol is less than. Since there's no is in there, that's not what they're talking about. They're talking about being lower by 50. And how do we get lower by 50? Well, if you had $100 and you need to be lower by 50, you take 50 away. So they want 90% and then take 50 away. Okay? So we could make it a P of X for profit if we wanted to. We're going to take F of X, but we're going to change it by what your profit margin is. So we do 0.9, which is 90%, times the 2x, and then we're going to take 50 off once we've gotten the 90%. Okay, so we multiply the 0.9 in, P of x equals 1.8x minus 50. And then we have to make sure we answered the problem. So we go look back at the problem, we look at the question mark and go back. What is your profit for 100 downloads? Well, downloads is x. So I need to plug in not x downloads, but 100. So I'm going to put a 100 in for x. So P of 100 is 1.8 times 100 minus 50. The profit for 100 downloads is 180 minus 50. So the profit for 100 downloads is $130. So we had to